Hello and welcome. In this tutorial, we will make the first tutorial program from the RoboDK help website. Let's open the help website. I'll go directly to the getting started section. The difference between our approach here will be that the getting started section is using a Universal Robot UR10 robot, and we will use the Universal Robot UR5 robot. So we will have to figure out some of the joint parameters that will be different from what are going to be given in the help files. So let's start. I will quickly skip through most of the text because I've already read that. I will only refer to those text elements which are important. So let's open the RoboDK is already open. So now we know and a new station is already there. You can see here open new station, and the new station will come here. In this section it is told how to open the library and download any robot. So I can also show you that. Help and open online library. Change. Or you can also open the online library from the website directly. Library, and you can select the brands or the reach or the payload or the repeatability, name or the weight, or by clicking here you can download any robot model. I already have the robot model with me, so I will use that. In this picture it is shown that they have already added UR10. I will just add UR5. Add item, and I have here my UR5. Okay. Now a bit about the screen and how to use it. Press the middle button and you can pan. Press the right button and you can rotate the view of the model, and left click can click an object, select an object, and if you press tab, if you press alt, you can do some movements. I want to demonstrate how to do these movements. Okay, I'll press and hold alt, and I left click the blue arrow coming out of the tool flange of the robot and drag it, and I can move the robot forward and backward as far as the Z axis can go. Similarly, I can go for the X axis, maximum out, X axis maximum inwards, and similarly for the Y axis I can go below and go above. So that is clear. And what to do about the curved arrows? The curved arrows are rotation about any axis. Like the red curved arrow, the arrangement is like this as given here: red, green, blue, cyan, magenta, yellow. Red is X, green is Y coordinate, Z is blue, cyan is first order angle, magenta is second order angle, and yellow is third order angle. So you can rotate about x-axis by clicking and dragging the red arrow like this or like this. You can rotate about the y-axis by clicking and dragging this arrow, and you can rotate about the z-axis by clicking and dragging this arrow clockwise or anti-clockwise. Then one thing to notice here is that there are three more squares: cyan, magenta, and yellow. This is cyan, this is magenta, this is yellow. What are these? These are planes. For example, this square is x and z plane. You can move the robot about this plane without going up and down. Without going up and down, you can move the robot like this. Similarly, the magenta plane is the YZ plane. You can move the robot in this plane without changing the X coordinate. And similarly, lastly, the Y plane is the XY plane, and if you click and drag by pressing hold the Alt key at the yellow plane, you can move the robot to center point TCP in the XY plane without changing the Z coordinate. Maybe I have mistaken. Behavior is a bit different. XY plane is okay. This is also okay. You cannot move it in the X direction. But when you click on the yellow plane, okay, this is right, actually right. There is no motion in the Z plane. Okay, enough about that. We can also see if we can move this. We can also move this from its space coordinate frame. So this is how the coordinate frame work in the robot. Let me just remove this robot and add again, because I played a lot with the robot. I want the correct positions. So next step is to add a frame 2. Frame 2, because there is one frame here, XYZ frame for the base joint, one frame for the tool of the robot. We want to add another frame for the part that we want to paint, and these numbers are given for that frame. In order to add that frame, we can select program and add reference frame. Add reference frame. So there's a frame, the plane is here. We double click on the robot, you can see that what is the tool frame, what is the reference frame, and what is the tool frame is reference to reference frame. I can quickly change the x-axis coordinate to 500 and see what happens. It should move towards left. Okay, not left, because right now the base frame has x coordinate coming out like this. So that is why it's moving in this direction. We can undo like this. Going back, let's try to enter these coordinates and see if they make sense. Robot should look like this, coming out and base wrist pointing downwards. Our wrist is pointing upwards. First we need to fix that. So we got one thing right. We have the shoulder on the right hand side. Then the arm should be backwards. Okay, I'll simply re-add UR5, and I'll simply add a reference frame, and as it is shown here in this picture in section number create targets, there are some joints given for the robot: minus 150, minus 75, minus 90, minus 60, 70 and 110. So I will double click on the robot and just enter these coordinates here. Minus 150, minus 70. Minus 90. Minus 60. 70 and 110. Okay. Another thing is shown here that the frame in the reference frame, you should select frame 2 with respect to base frame, and these coordinates should be entered there. So we can go there, and already frame 2 is there. We can enter minus 800, 500, 100. And also there's an angle of 180 in the yellow. Positive 180. Something does not seem right. Okay, so I have defined these settings for the frame 2. You can see here the settings are there as per the guidelines. So we can move on step by step again from here where we were. First step, add a reference frame, that is done, and import 3D object. Open and select the object inspection from the library. Open, okay, object is added. Alternative, drag and drop files and body. Drag and drop the object with the reference frame frame 2 inside the station 3. And we have to cut and paste the object in the frame 2. Cut the object and click frame 2 and then paste. It will be aligned with frame 2. Okay. Now we have created TCP. Click open, and the guidelines say that select the paintgun.stl, but we have to select the paintgun.tool from the library. Open paintgun.tool. Already it's attached to the robot tool flange. You can see from here it's attached. I want to rotate this one a bit. Question here. What is this? It should be in degrees. Tool center point with respect to UR10. What about this one? frame should also be in degrees. That is the problem. We should select stably and then select 180. Okay, this is corrected. All these settings are talking about something, and we have to set this one. Tool name, paint gun, 70, 470 and 35. Tool center point with respect to tool flange, with respect to UR10 flange. This will be a problem because UR10 is a bigger robot in size and UR5 is smaller, so these coordinates will not match. Let's try these coordinates and see what happens. We just added the paint gun dot tool and we need to enter, we need to double click the paint gun and then enter some coordinates 50, 450 and some numbers are given there. Let's see what's asking me to do. It's asking me to select the stably type format of entering coordinates and 70, 470, 35. Stably type format 70, 470, 35. So that's what it's asking. If you see, it's not too bad. It's near to the part. We should save our project at this stage, and now we fall into sections that are show hypothetical situations that require the TCP in different ways. We will skip these two sections like the set a relative TCP and move the tool geometry. We will skip these two sessions and go direct to targets. Robot positions are recorded at targets. Follow these steps to create two targets, one new home and approach target. Double click the robot to show the robot panel. Select the paint gun tool frame once the reference becomes active to a green dot. This is already, I think, working because the paint gun is the tool frame. Select the frame 2 as the reference frame. That is also working. Frame 2 is the reference frame. Go to program and teach target. Now if you see, our situation looks almost similar to this one. Compare these two scenarios. Let me orient like this, more like this. Almost slightly, this spray gun is slightly ahead of this part in this diagram. So we are doing approximate calculation here, so still this will work for now. So if we compare our tool frame with respect to reference frame, What are the coordinates? -89, 592. They are different. 413, 188. They will be different because this is a smaller robot. There will be differences in the coordinates. Program teach target. Program teach target. The target one is here. Now what we need to do is rename the first target as home. Rename it home and program teach target button new target. I will do one additional step. I will right click it and teach current position as home. This will be the home position for the robot TCP. Next we need to do another program teach target and name it approach. And when we do that, we need to double click that and give some coordinates to that, given like here. So I will go here, programs, teach target, rename, approach, zero zero 200 minus 180 0 minus 180. Let's double click this one. There was somewhere where I found change configuration option 0 0 200 minus 180 0 minus 180 minus 180 0 minus 180. So this is bad. This is not good for us. Or is it? Again, it should be Stably. It should be Stably type coordinate system. Let's look at the joint position. They are not matching. The joint will not match. Yeah, they are two different robots. UR5, UR10 are two different robots. They are two different joints. Uh, that link element lengths. Let me do it once more. Program teach target options 0 0 200. This 200 is a bit higher side. I will reduce it to 170. Okay. I also have to change this one. This minus 180 is good. And what is the second 0? This is 0. This is also good. So let's keep it like this. And something is not right. Maybe this position is unreachable. Options. It's not moving to this position. Position is unreachable. Probably I have to move the part more closer to the robot because the robot does not have that much reach. So now I think we have some suitable position, and let's try to, okay, this time it has accepted the robot pose. So we should teach it, teach current position, and move forward. Add an approach program, add program, and rename it to approach program. Program, add program, rename it to approach move. The next step is to select the program and move to add instruction. As we can see, we have two targets, home and approach. Second target should be named to approach. Now we can add the joint instruction. There's some trick that we missed here, and that was that select the home target and then click program move joint instruction. After the program, add program and rename it to we have to click the home target and then select program and move joint. This time the frame and the paint gun reference are coming with it. That's what it's saying here, that two instruction will be added automatically with tool frame and reference frame we are using. And select the approach target, and now select the approach target and click program move joint instruction. Approach target and click program joint instruction. As you can see, it's moving from these 2 points. Now to create targets on surface, select each targets on surface and then select 10 targets, select 1, 2, 3, 4, 5, 6, 7, 8 targets like this. 3 to 8, 3 to 10, 3, 4, 5, 6, 7, 8, 9, 10. So there are 8 targets. Now what we have to do is just program each target on surface and then just click on these will be perpendicular to the z-axis of PCB normal. That's for sure. Each targets on surface. Now you see the robot is moving with it. The TCP is moving with it. I want to zoom in a bit. Let me do it one here. I think there is the limitation of the robot. It cannot move that far out, and there is a singularity. You see here, this is the robot is fully stretched out. So we should not use this. You skip this one and skip this one again. And it's best we close the program and restart it again. Okay, and what we do is we try to move it bit backwards so that it can come inside the work zone. Or what we can do is we can do one more thing. We can do here view, and we can see here what workspace is. Now it is within the workspace. Previously the part was outside the workspace, or right about at the edge of the workspace. So certain positions of the TCP were not possible due to singularity. So now I think a better view, I can move it in between here. In this way we can have better movement of the robot. So I can remove the workspace view and again go to each targets on surface. Now I'm back in business. 1, Let me do 3, 4, 5, 6, 7. This one is a bit tricky. We have 8 targets on the part itself. The next step is right click somewhere, done, and select all targets rated 3 to 10 and rename group paint top. Rename group paint top. Right click on the targets again and click create program. Create program. The program is created for all of these things, and add a retract program. Program, add program, program, add program, rename it to retract. When the robot places the last target, move the robot upward by v coordinates with respect to the reference frame in the robot plane. What we have to do is we have to go to the UR5, double click that, and it's 470, make it 500. I think there is some help here. This is the parameter we need to change. The tool frame in the z-axis is we have to increase it up by some margin. 22. Let me change it to 50. It's going upward. That's what we need. So we need to make new target. One step remaining from the previous step. We have to give it some name to the program. In into paint top. This is paint top. And lastly, change that. Now move linear, keeping click here, just go to here and click move linear. My mistake, I changed. I click that. That means I will have to delete the whole program and then add program, retract. Click retract, then click move linear. The move will be set, move is there. And next what we have to do is select the home target and then program move joint instruction. Select the home target and then program joint instruction. Okay, we are done with this one. Lastly, we have to do the main program. Program, add program, end program, program call instruction. Program, add program, rename it to main prog. Then go to main call instruction, then just select from this approach move. Okay, first one is there, then program call instruction, select program paint top. Okay, second is there, and then the third one, program call instruction, select program retract. Okay, so the three programs are there, and now we can run the program, run the whole program in one go. Let's try. And we can make it run in a loop. Double click. This time when it will run, it will keep on running in a loop, and you can see in the bottom bar it says that what is the path length, what is the time it is taking, program time for approach move 4 seconds, paint top 27 seconds, main program 30 second plus. And all the uh, coordinates are changing here. You can see that the robot joints angles are moving. You can see that the tool center point coordinates for x, y, and z, and the the uh, axis angles are moving. But the reference frame is stationary. and also the tool frame of the paint gun with respect to the robot flange is also stationary. So that concludes our simulation. We can add the macro for the spray simulation in the developed in the Python language given here. Just open and go to macro and select spray on. I just close the program or stop the program. I open library, macro, spray on. The spray on code is here. I'll just uncheck the loop and run from here, and this will allow me to add this program in here. Click on the main program, then click program and call instruction, select the spray on, and I have to do it from here, approach. Uh, Call instruction, spray on, then you have to do spray off. Okay, now it should, let's loop the command main program and then start running it. Let's see, it starts from the beginning. This time it's spraying the color. You can see here the color is being sprayed. I will just remove the let's try one more time. Before that, let me try to see how I can reduce the size. Reference frame smaller. View reference frame smaller. We cannot reduce any even more. We can smaller. Reference frame is smaller, and the text, should we show the text? Now the screen should look better. We zoom in a bit, pan a little bit, zoom in a little bit more. This should be pretty sight. Yeah, our robot is painting now. And we can also view it in such a way that our tool, we can trace it. Okay, this concludes the simulation. Everybody can do it. Everybody has a demo version of RoboDK simulator. Uh, One last thing to do is pause the program and generate the program. Right click on the main program and click generate robot program. What will happen is it it will generate the robot program, and there will be two instructions, spray on 1 and spray on 0, which are the Python instructions. These should be removed before downloading to the robot controller. And if you can see here, the robot code is mostly made up of uh, some variables like speed in milliseconds, translation and rotation speed, translation and rotation acceleration, blend radius, then some TCP settings, then move J and move J, then move J, move L, all move Ls, then move J and move L and move J. So it's very simple, just coordinates and these parameters given above here. That is what makes up the actual robot program. So such a robot program can be designed and simulated inside a simulator and then automatically generated and then download to your robot to test instead of directly teaching from the uh, teach panel.